Good. Good afternoon, everyone. Thank you for being in this lovely space, which echoes. Does it echo to you or not? It's all right. Okay, thank you very much. So I'm Mary Scholes. I work at the School of Animal, Plant and Environmental Sciences at WITS. And most of the time I try and work in understanding the relationships between soils and plants and the atmosphere. And there's a big word for that. It's called biogeochemistry, which is what we call ourselves these days. In the old days when I was training, we called ourselves botanists. Then we migrated and we called ourselves physiologists, because I understand how plants work. And now the kind of problems in the world today are not of a nature that we can solve them with any one discipline. We have to bring together these various disciplines, and you will find all over the world the training that new students are getting is essentially not in anything anymore called botany or zoology. It's in a much broader interdisciplinary field. So what I would like to do today is to just take you through some of the different kinds of interactions that I think are remarkable in terms of the way our plants are structured and the way they interact with their environment, bearing in mind that Africa is one of the oldest continents, and essentially it has stayed where it has been forever, like a good child in the family. And whereas all the other continents, Australia and South America and India, they all buggered off. We're pleased that some of them left our shores and left us where we are. So we are a very, very old continent, but what that means is we've had plenty of time to diversify, which effectively is a very good thing in terms of coping strategies in life, but it also means that the soils on which plants grow are what we call nutrient poor, because soils are kind of like a child's toy box. They get filled up at the beginning with blocks and rubber balls and teddy bears and all those sorts of things. And then over time, depending on how disciplined your child is, they throw bits and pieces away. So you've got one block left and one doll's head and one teddy bear's arm, but you can't necessarily reconstruct it back together into a toy box unless you add things back into the system. And that's what happened over millennia on the African continent, is that it's rained, in some places heavier than in other places, but over time the nutrients that were in this toy box have essentially been lost to the ocean. And that's why the sea is salty, because the elements that move most easily are the simple salts, like salt, sodium and calcium and magnesium and many other salts. So the reason why I give you this small introduction is that many of the interactions that we see between organisms on the African continent are compensating for the fact that they are living under nutrient stress in most cases. They've evolved in an environment where there are not enough nutrients, and they've had to go out and essentially make alliances with other organisms to make sure that the nutrient transfer takes place. So with that introduction, and please interrupt me if you don't understand something. That's a typical picture of what we would call the bushveld or a savanna system. And most of the systems that we work in Southern and Central Africa and West Africa look something like this. They have grasses and they have trees. And they're usually in a rainfall gradient of between about 500 and 1,200, 1,500 millimeters of rain. And what that means is that the trees have enough rainfall to grow, not very tall, but they don't have enough rainfall to make a big enough canopy so that all the trees make one big layer. If they made one big leaf layer, then we would be in a forest, and you could look up and you wouldn't see the sky. Whereas in savannas, mostly driven by rainfall but also by nutrients, we can look up at the sky and see the sky. And essentially that's how we define a savanna. Grasses in the bottom layer and trees in the top layer, and the number of trees is what varies. And one of the interesting questions is, what controls the number of trees in a system? So this kind of vegetation we often call the sauerveld, which is terminology you may have heard in South Africa. It means that when the animals eat the grass and eat the trees, because there's very little nutrients, it tastes to them sour. Okay, that's the fundamental understanding of the sauerveld. The biochemistry is much more complicated than that. But the trees that grow in this kind of vegetation have broad leaves, have leaves that are about 0.5 centimeter across. So that's what we mean by a broadleaf tree, and they don't have thorns. Alternatively, you get a typical picture like that, which we would call acacia savanna. And the leaf of the trees here is much, much smaller. Little acacia leaves, and they're higher in nutrients. And when the animal eats those tree leaves and the grasses that grow there, they taste sweet. And this is what's called the sweet veld. And that's why we have these two very broad classifications in the country, or all the way up to the equator, of what we call infertile savannas with broadleaf trees, and fertile savannas which have fine leaves. That correlate holds together wherever you go. Now, I've used the words sour and sweet, and if I speak about those two words to you and I, does sour and sweet mean something like sugar to you? Something is sweet, you think it's got sugar in it. Something is sour might have less sugar or there's higher acidity. Now, that's unfortunately the way that the early people described this veld, as sweet and sour. It would have been much better if they described it as infertile and fertile, because the key nutrient that allows an animal, that's a grazer or a browser, to make up in that animal's mind that it tastes sweet is if there's nitrogen there, not anything to do with sugar. Okay, so they could have called it sour, infertile, nitrogen poor. All right, so forget this idea of sauerveld meaning that it has no sugar, or that sweetveld has lots of sugar. That's nonsense. Sweetveld means it has lots of nitrogen. Okay, got that? Everyone understand that? Okay, good. All right, now I can move along. I sometimes have students that go, and they look really smart, and then I ask them like half the way through, have I mentioned the word nitrogen yet? And they all go, I don't think so. so I'm very used to people not understanding. Yes?
Sorry, how does the nitrogen get there?
I'm going to tell you.
Oh, okay.
Okay, so how does the nitrogen get there? So nitrogen is a gas. It's all around us. There's lots of it as a gas. There's very little of it in a form that plant roots can take up from the soil and therefore put it into the leaves for the animals to eat. So plants have thought about this for a long time, and I'm sorry if I sound that I'm anthropomorphizing. Is that the big word? Making plants look like they're thinking, okay? The fact is that the system works so brilliantly, we've got to have some kind of belief that it's working towards optimization. And I don't like to talk about Mother Nature and the balance of life and all that nonsense, because those are the values we place on the system. Essentially, the system is functional in terms of what it's supposed to do. So, this nitrogen sits up in the atmosphere. Animals need nitrogen in order to build mostly muscle tissue, just like we do, muscle and genetic material. But what happens in the way nitrogen cycles in the system It comes down from the atmosphere, it goes into the soil, and explain the process of how it gets transformed and taken up in plants. Now it's sitting in the plants, and in Africa, every year, in various parts, it burns. So we have fires, and if you burn grass or tree leaves at a high temperature, all that nitrogen that you've gone to the trouble of fixing from the atmosphere, poof, it just goes back into the atmosphere. And you may say, oh, but that's really clever, nitrogen in, nitrogen out, being used a little bit. That's fine, provided the amounts coming in and the amounts needed optimize the functionality of the system. So that's what we mean by nitrogen has an open cycle. It comes in, but it burns off. Maybe not every year, but at least every 3 years in our savannas. So what has happened over hundreds of thousands of years has been the development of a process called biological nitrogen fixation. And I'll explain it to you now, but it brings together the concepts of nutrient poor, nitrogen, and phosphorus areas.